we have to learn equation for path of projectile. So let me consider a projectile is projected with initial velocity u in upward direction. Initial velocity u in upward direction, which make an angle theta with horizontal. So let me show it in a diagram. You can see this is a x-axis, this is y-axis, and this is the trajectory of projectile. Now its initial velocity, you can see here, u is the initial velocity. Now this initial velocity is resolved into two components. So one component which is along x-axis is called as u cos theta. You know that cos theta is what? Adjacent component divided by hypotenuse. If I consider, so this is initial velocity u, this is theta, then adjacent component we can call it as a ux, and this hypotenuse is u. So we can write cos theta is ux by u. So ux component along x-axis is u cos theta. So you can see here it is written u cos theta. Similar manner we can write the component along y-axis is u sin theta. So along y-axis u sin theta, along x-axis u cos theta, or we can call it as a component uy and ux also. Now after that, so we know horizontal distance covered by projectile in time t. So we have an idea about a formula of velocity, distance by time. So by that, horizontal distance is equal to horizontal velocity into time. Now here, horizontal distance is along x-axis, so I can use x for that. And horizontal velocity along x-axis, you know that this is u, and component of velocity along this axis is ux, or you can call it as u cos theta. So u cos theta into this t. So by using that, we can write t is equal to x divided by u cos theta. Now, by second kinematical equation is ut plus half at square. So by that equation, along y-axis, this equation we have to write along y-axis. Then we have to substitute here s is equal to y. S is the displacement. So displacement along y-axis is the y. Then u is the initial velocity. Initial velocity along y-axis I can write uy, or that uy we can write u sin theta. Then acceleration along y-axis I can write ay, or it is equal to acceleration due to gravity minus g. You remember one thing here, acceleration due to gravity is always acting in a downward direction. So it is always negative. So always we are using minus g. Hence, we can write this second kinematical equation by substituting all these terms in this equation. So y is equal to u sin theta into this t plus 1 by 2 minus g into t square. And this t we can substitute here as well as here. Then what we get in the next step? So listen, this t we have to substitute, and t is what? X divided by u cos theta, that you remember, that we have to substitute in this equation. So let's see. So y is equal to, so this t we substitute as a x divided by u cos theta, and here x divided by u cos theta square, then we get this equation. Now we have to simplify this. So how we can simplify? We can cancel the common term, this u get cancelled. Then sine theta divided by this cos theta is tan theta into this x. So we can write x multiplied by sine theta divided by cos theta. And this minus sign we written here. 1 by 2, this g, then this x square divided by this u square into cos square theta. So we get this. Then sine by cos is tan. So y is equal to x tan theta minus gx square divided by 2u square cos square theta. And this is equation for path of projectile. Now here, if you see this equation we can write this tan theta and this term. So this equation we can write y is equal to this tan theta I can write a, this x, minus this g upon 2u square cos square theta I can write b. A and b are the constant, bx square. So this equation is in the format of ax minus bx square, and this is an equation of parabola. So therefore, we can conclude that the path of projectile is a parabolic path. Our path we can call it as a trajectory. Trajectory of projectile is a parabolic path. Question may be asked, show that trajectory of projectile is a parabola. Then you have to write up to this equation and then you have to write this conclusion. I hope everyone understood this